Hello, everyone. My name is Muhammad Khalafallah, and in this presentation, I would like to describe the steps followed to create a cost-based decision-making tool for design bid-build projects. This presentation is based on the research that was done at Auburn University and the paper published in TRB of 2018. So let's just start with what are the outlines of this presentation. So in the beginning, I'm going to talk a little bit about what is design bid build and what are the different types of compensation approaches within design bid build. And later on, I'm going to touch base on some of the key elements of our literature review that was done on our research, and also um, what are the states that are developed a guidelines to govern the specific type of design bid build projects. Then of course I'm going to talk about the methodology was conducted in our research, the results, and how we developed the framework, which was actually in the form of a nomogram. And then at the end I'm going to briefly discuss some limitations and future research that are I would say valid to our research. So let's get started. So what is design bid build? So the abbreviation is DBB. So for this presentation, I'm going to mention DBB a lot. So let's just say DBB is an abbreviation for design bid build. So in design bid build in general, design is fully accomplished by the owner. In our case here is Florida Department of Transportation, because most of the data or all the data that we are going to discuss here in this presentation, we acquired it from Florida Department of Transportation project database. So the design is fully accomplished by the owner, or what we call in-house. So in-house also might include hiring someone as an engineer or a consultant to do the design for you. And the construction of the project is awarded in a separate contract. So why are we discussing design bid build, or why are we conducting our research in design bid build? Most of the projects that are right now in the, at least I would say in the transportation industry, were procured through DBB, with more than 70% of DOT projects are done through DBB. So it's quite a lot. And also worth mentioning that most of the recent research, or at least in the last 2 decades, in this area was actually focused on comparing DBB with other delivery methods like design build or construction managers at risk. But none of the research, or at least I should say, that I've looked into recently, was actually comparing the different types or techniques within the DBB itself. So type of DBB that are discussed in this presentation is the first one is the unit price, where the compensation is based on the actual amount of work performed by the contractor, or it also could have like different names that you can call it: a cost per unit contract based or itemized contract based. So you would find in the contract documents are the quantities of each pay item, and then the contractor should put the price per unit, such as per cubic yard of excavation or linear foot for guide rail. The other type that is going to be discussed here is the lump sum. So which is actually just a fixed amount of money the owner will give the contractor. So the contractor will submit his proposal as just a one price. Why do agencies and DOTs use lump sum because it reduces the effort of the contract administration required to verifying the quantities in the field, and will enable the inspectors to focus more on quality aspects of the project. So what are the objectives of our study? Is actually to develop a methodology or a framework to be able to objectively identify DBB projects that to be procured through lump sum or unit price. In our study, we're only concerned, or this study only discusses specific type of projects, which are resurfacing projects. So when we were looking or surveying the states that are using or developed a specific guide to use lump sum contracting method, or I would say compensation approach, we found only 6 states that are developed or in the developing process of a full guidelines to govern the use of lump sum, which were Florida, Michigan, Colorado, California, and Alaska. And also we found that Texas is in the process of developing the guideline. So by now, I guess they probably already developed that. We found also other states, which were Washington and Montana, that they developed a guidelines, but only for to be used for traffic control projects. So what are the advantages of using lump sum that were found, or like all these states agree on? Was actually that using lump sum reduces contract administration. So it will, as I said, as I mentioned before, it frees the inspectors to focus more on the quality of the work performed by the contractors, and since it's freed their time from verifying every quantity that the contractors did or performed. It also simplifies the payment process, since it's just a one payment. So the contractor will get the payment or the full payment at the end of the project, or on a schedule that was agreed early upon before starting the project. It also, as I mentioned, allows inspectors to focus more on quality instead of verifying the quantities of work performed. It also provides the contractors with the flexibility to select the methods or means to do the job there. With the unit price, for example, usually the work is specified specifically. If you want, for example, to paint a wall, it will tell you exactly how you should paint that wall. But in the lump sum, you would just say that this is an item. We need this wall painted with this, let's say with this specs, for example, but it does not specify you should start from right to left or left to right. So what are the disadvantages of lump sum? It has, or I would say, like, it possesses a great difficulty in pricing changes, since there is no benchmark to measure the prices. With the other type, the itemized or the enterprise, usually if you want to build a new wall that was not described in the original design, we already have like other walls that were supposed to be built there. So we have a baseline of how much this wall will cost. But here, since there is no breakdown of the prices, it's very difficult to price the changes. Same thing, also has difficulties in identifying extra work. And also contractors tend to put more contingencies or more money in their proposal, since they think this is like more of a black box, or I should say like a more risky way of pricing a contract. So they always tend to put more money just to account for the uncertainties that might happen in the future. And also it requires higher design quality from the owner, since you don't want the contractors to put more contingencies in their price proposals. So these 6 states, we found that they agree on set of projects that they would select for lump sum. They would select usually a well-defined project in scope of work to all the parties in the project. They will also select only the project that has low risk of unforeseen conditions, and also project that has low possibility for scope changes during all project phases, and also low possibility for contractors to provide less than the required quantities of work, since you don't want to pay contractors for more than what they did. So also I found in these guidelines that they provided some examples of project that they would use or select lump sum. They said the most suitable project would be like stuff like bridge painting, fencing, or guide rail, excuse me, intersection improvements, landscaping and lighting, simple milling and resurfacing, minor road widening, signing and traffic marking, simple transportation enhancement projects. So you could see here, most of these projects, or all of them, are like simple tasks, or I shouldn't say simple, but it is like very clear. There is nothing unforeseen in doing all these projects. So the least suitable would be urban construction and reconstruction, rehabilitation of movable bridges, project with subsoil earthwork, concrete pavement rehabilitation, major bridge rehabilitation repair. So if we look at these projects, you would find that all the rehabilitation projects, it involves like, so the amount of work that you do usually in rehabilitation is not specifically defined. You would say like repair this wall, but we don't know how to measure the repair in this wall, for example, unless you start doing that work. And also project with subsoil earthwork, definitely when you have something that beneath the soil that you don't know exactly what are you going to encounter in the project. So this is a level of uncertainty that is not desirable with using lump sum. So the methodology that we used or employed in our research is here. So we, as I mentioned before, so the database that we used to develop our model were projects that were acquired from, or project data that were acquired from Florida Department of Transportation, or FDOT. So the database that was from January 2015 to March 2017. So we were able to retrieve 1,275 projects within that period, and 705 unit prices project and 200 lump sum projects. So the rest of the projects that, if you can see, is like it had different types of contracting method, because we had the DBB projects were like about 905. The rest of the projects were about were like design build or P3 or either construction managers at risk. So what we did, we conducted the literature review, we collected the data, as you can see, then we cleaned the data. We only extracted the relevant data from the resurfacing projects that we would use. Then when we came to the data analysis process, we developed 2 different models to join them at the end of the research to create our Nomogram. So we developed deterministic cost estimating models using nonlinear regression for both projects that in the study, the UP and the lump sum. Then we developed cost growth models, and then we developed a stochastic model by joining the deterministic and the cost growth model. We did also, to be able to have more scenarios in our model, we developed a statistical comparison of stochastic cost estimates. We used Monte Carlo simulation to generate different scenarios to our model. Then we integrated our results and we developed a nomogram. So in the data cleaning process, so we had 3 steps that we followed in the data cleaning process. So we picked only the projects that the scope of work exclusively focused on resurfacing activities. That means other types of work were discarded. We only picked the project that are completed or it was marked as final payment was made to the contractor. So to be able to measure the final cost of the project. So we only also selected the projects with a uniform road cross-section along the project to facilitate the calculation of construction per lane mile. I should mention is when we collected the data, we usually divided the data like by lane mile. Lane mile means is if we find a project that has like, let's say the whole project was like 5 miles, but it was 3 lanes in each direction. That means like 6 lanes over. So we would say this project is actually 5 times 6, which is 30 lane mile. So we were trying to also pick the road, or we only pick the road that has uniform road cross section. So for example, if we find a road like this that has this jog that like you see like the cars are going like from 2 lanes is going to be 1 lane, so we would not pick a project like this. Examples of a project that we would pick from this picture from Google Earth. This is I think like interstate. I think it's like I-75, as I recall. See, it's clean, and also a road like this. So some of our results were like when we collected the data. So this is the tables that we use. We have like the project number 1, so like the number of the project, the number of miles, or what I should say lane miles, then the original cost, and when we did the when the FDOT did the contract in the beginning, and then the actual cost at the end of the project. And then you see the cost growth here in the last column. Also for lump sum, same thing. So how did we develop the deterministic cost estimating models? We plotted all the lane miles project, every project, and we plot these numbers as a bid price per lane mile. So as you can see, with the number of lanes in your project, then of course the cost per lane mile would go lower. So we did that for unit prices projects and lump sum projects. We came up with we found the trend line has these 2 equations. So we joined both trend lines together to come up with this graph. So in this graph, if you see that it will tell you that it's better to use lump sum from 0 up to, let's say, approximately 20 or 21 miles, and then it would be, you would have a lower cost per lane mile if you would use unit price above 21 miles. But this is just a deterministic part of the model. So for the cost growth model, we use this equation. So we used, we say like the percentage change of the actual cost. of the cost of the project at the end of the project. So is the actual cost minus the original cost divided by the original cost. So what is how much the project cost change at the end of the project from the original contract price. So in this here, we plotted the data that for the unit price, we found that to follow a normal distribution, and it follows extreme value minimum distribution for the lump sum. We also did this for illustration, just to see both together in one graph. So the stochastic cost estimating model, or what we say probabilistic estimating models. So we joined both the the deterministic and part here. That's what we developed, and the probabilistic or the cost growth model here in one equation. With X is the number of lane miles, and for example, for the unit price model, and here is normal distribution, and between the brackets is mean and standard deviation. Same for the lump sum model. We have this part, which is like the equation that we got for the lump sum, or the trend line from the deterministic part of the equation. And here is the extreme value distribution, or the probability distribution that we got from the cost growth. So what we did is we did this stochastic comparison, which was we came up with hypothetical 50 projects or 50 lane mile project on the for this. So with the number of X, so we had, that means like had 50 different scenarios on the deterministic part, and we ran 10,000 iterations using the Monte Carlo simulations on these 50 projects. That means we did, so the number of simulations were done was actually 50 times 10,000. So the comparison of 10,000 pairs of simulated values per project size. So we did. So at the end, when we did the simulation, so we found that the data, or the distribution of the data, would follow this graph. So that means if you look at the 50% probability, where after more than 50% is better to use unit price, and less than 50% is better to use lump sum. So in the graph, these plotted numbers, we plotted the number of times the unit price estimation exceeded the lump sum estimation. But since we don't want to just give the decision makers just like one number, hey, because we don't know, things are not like black and white. There might be other factors that are involved in this. So what we did is actually we developed this nomogram. The nomogram will have, so the decision maker will use two inputs. It will use number of lane miles, or number of miles in this project, and the confidence level he wants to use. So the nomogram will give you these outputs. It's going to give you the probability of unit price will cost you more than the lump sum, or also will give you also the expected case scenario, worst case scenario, and best case scenario. So this is the nomogram. So if we see the red lines is an hypothetical project. So let's say hypothetically we want to use a 20-mile project. So as I said, the inputs are the number of miles and the confidence level. So if we decided to use 75% confidence level, so if you say 20 and 75, so if you go to the best case scenario, So the best case scenario, you either going to save $13,000 for each lane mile if you decided to use lump sum, or you're going to use, or you're going to lose $11,000 for each lane mile. So this is where the contribution of the paper of our research. Also, I would like to mention that also here the expected case scenario is actually you are going to save $2,000 if you use lump sum. So limitations of our study and the future research. So the limitations, only this nomogram or this study is applicable to resurfacing projects only. It also assumes the same quality. So decision will not affect the construction method. It also the cost performance was done using only the construction cost. So the future research, would suggest that to study additional project areas affected by provisions such as quality, design cost, and administration and inspection cost. And also develop such models for other types of work, not just resurfacing. Thank you guys for your attention, and I hope you liked our presentation.